aqueous NaCl, what exactly does that mean? Just understand. When we have this aqueous NaCl, it would mean it contains NaCl. Along with that, it contains water. So how do you think NaCl breaks? NaCl breaks like Na plus and Cl negative, and water breaks like H plus and OH negative. Am I right or not?
Yes.
Got the point?
Mm.
Got it? So
Yes.
the idea here is what? We are going to have NaCl and we are going to have H2O.
Yes.
So how does water breaks? You know, water will break like that. Now, last class we studied a list. We studied a list of anions,
Mm.
right? When we studied the list of anions, what exactly did that had? Understand. So we had SO4 minus 2, we had NO3 minus 1, right? We had we had F minus 1, we had OH minus 1, then we had Cl minus 1, then we have Br minus 1, and then we had I minus 1. Am I right? And
Yes.
we said that when we move down the series, their tendency to release electrons, their tendency to lose electrons decreases.
Mm.
Am I right? So when their tendency to lose electron decreases,
Isn't it?
tendency to lose electron increases.
Yeah.
So when we say that the tendency to lose electron increases, what exactly does that mean? That they're going to lose electrons? And
Mm.
once they're going to lose electrons, okay? Once they're going to lose electrons, what exactly does that mean? Just tell me. Once we have the tendency to lose electron, so we will have a list of anions. And these electrons will be lost, and we'll have sulfate, nitrate, fluoride, hydroxide, chloride, bromide, and iodide.
Mm.
Got the point? So here, out of Cl negative and OH negative, got the point?
Yes.
So we are going to have the Cl negative and we are going to have the OH negative. Got the point? Which is going to be deposited. Cl negative will deposit itself. So we know that we have two anions here, and both of them will run towards a positive plate. The
Mm.
idea towards reaching the positive plate is what? That OH negative will go and lose electrons. Got the point?
Yes.
And when that happens, so it is going to lose the electrons.
Mm.
Got the point?
Yes.
And when this happens, what exactly happens here? Tell me. So we're going to have OH negative, we are going to have Cl negative, and who loses electron? Because this rod also wants to become neutral. So this rod is carrying a positive charge. Am I right or not?
Yes.
And then when you lose electrons here, what does that mean? That we are
This.
going to have electrons given by OH or Cl negative. But since Cl negative is at the bottom, it will lose electrons. I'll tell you this series that we have made, if you are a little bit aware of the resonance, I'll tell you why this happens. Let's say we have sulfate. Okay. So sulfate basically has negative single double. So this resonance is there. And because of this resonance, the negative charge is very, very tightly packed. You understand? This negative charge is very, very tightly held because of the resonance part. Am I right?
Yes.
And because of this resonance part, this electron is very tightly held. I hope you're understanding. And when this electron is very tightly held, what exactly does that mean? Just tell me.
Won't lose electrons
Yeah,
easily.
that is why. That is why sulfate is at the top and it does not loses electron very easily because of resonance. It does not loses electrons very easily due to its resonance. Am I right or not?
Yes.
So when it does not lose electrons due to its resonance, that's the basic idea we have. You understand the point. So you understand that when we have sulfate, when we have nitrate, when we have fluoride, when we have hydroxide, and all of that series, okay? So that is how the series is made. So we know that out of OH negative and Cl negative will go and deposit itself. Okay. Now similarly, we have a series of metals. Okay. The series of metals that we have is basically sodium, potassium, calcium, aluminium, Fe, Sn, Cu, Hg, Ag, Au, Pt. So we will have K plus 1, we will have Na plus 1, we will have calcium plus 2, we'll have magnesium plus 2, We'll have aluminum plus 3. So you understand that all of these neutral atom ions, they will kind of lose electrons to make some, you know, they will kind of lose electrons to do what? To acquire some charge. You understand the point? So
Yes.
what is exactly happening here? You understand? So as we arrange the series along this down the series along the element, So here the metal reactivity series, here the metals reactivity goes on decreasing downwards. You understand the point? Here the metal reactivity goes on decreasing downwards. And because the metal reactivity goes on decreasing downwards, what do you mean by the metal reactivity? It is the metal's tendency. It is the metal's tendency to lose electrons. It is the metal's tendency to lose electrons. Am I right or not?
Yes.
So when it is the metal's tendency to lose electrons, what exactly does that mean? Just tell me. What exactly does that mean? So when you say it is a metal's tendency to lose electrons, that would mean the atom which is bigger in size will have the electron very far off. And the atom which has very small size will have the electron closer by. So as the electron is far away from the nucleus, it is going to do what? It is going to experience less force or attraction.
Yeah.
Whereas this electron will experience more force of attraction. Yes or no?
Hmm.
So exactly what is happening? Just tell me. When this electron is experiencing less force of attraction, and when this electron is experiencing more force of attraction. So you understand that we are arranging these metals from top to down, and we are saying their tendency to lose electrons goes on decreasing. What do you mean by that? When I say that the metal tendency to lose electron decreasing, what exactly does that mean? Just tell me. Just tell me. When their tendency to lose electron goes on decreasing, what does that mean?
All
That
of the same.
exactly as we move downwards, what does that mean? Tell me.
Size will become smaller of the atom, and thereby electrons will be tightly held because of the force of attraction.
Yes. And thereby the reactivity will decrease. Now understand. So now similarly, if we have a potassium, and let's say we have potassium K plus, obviously potassium is at the top, so its size is going to be bigger. And you look at copper is at the bottom. That means its size would be smaller than that regards to Cu plus 2.
Hmm.
Am I right?
Yes, ma'am.
So you tell me, now we have one electron here and one electron here. Where do you think that this electron will be attracted inside the atom? The bigger atom will attract it faster, or the smaller atom will attract it faster? Tell me.
The smaller one.
The smaller one. So you have to understand that the smaller atoms they gain electrons faster,
Hmm.
whereas the bigger atoms they do not gain electrons extremely fast. But the bigger atoms they are very good at losing electrons. Am I right or not?
Yeah.
So what is the idea? The idea here is that we have two cations, and these two cations are kind of wanting to compete to reach and gain electrons at the cathode. The cations they move at the cathode. Am I right or not?
Yes.
So what exactly does that mean? That if I have a beaker and if I have aqueous solution, so from aqueous water we have H plus coming,
Hmm.
and from NaCl we have Na plus coming. So I hope you're understanding what do we have here.
Hmm.
So we're going to have Na plus and we're going to have H plus, and we are going to have OH negative and we are going to have Cl negative. Am I right or not?
Yes.
Got the point?
Yes.
And when this happens, so this is the negative terminal. The battery has done its part. The battery has played the role of a pole, and it has taken all the electrons from the anode and it has transferred these electrons here to the cathode. Yes or no? So
Yes.
this rod will thereby gain a lot of electrons. And when H plus and Na plus goes here, you look at the reactivity series of all the cations. Na plus is here, and H plus will be here. Who do you think will be smaller in size, Na plus or H plus?
H plus.
So who is going to gain electrons faster, smaller atom or bigger atom?
Smaller atom.
Smaller atom. So out of these two cations, definitely now, because why am I saying this? Because Na plus has already lost its one electron. H plus has already lost its one electron. So when
Yeah.
H plus goes there, so that H plus it tries to gain that one extra electron and it forms H neutral. So when you have two H plus, it goes and gains two electrons. So it forms two H. So it becomes H2 gas. Am I right or not?
Yes, ma'am.
Got the point?
Yes.
So how do we write down the equation? So I'm going to make this table again. So I'm going to say I have a beaker. I'm going to have the two rods. So this is negative and this is positive. And we are going to have Na plus and Cl negative, and we are going to have H plus and OH negative. The two anions will run there, and the two cations will run there. So at cathode, what do you think is going to happen? At cathode, we have a competition between, because at cathode, the cathode is richer electrons. So cations go to cathode and accept one electron. Cations goes to cathode and gains one electron, one or more electrons, and hence you understand the point.
Yes.
And they gain one or more electrons, and hence what do they do? Tell me. And hence become neutral.
Mm.
So out of two cations, we know that H plus is smaller in size. And here we have the work of gaining electrons. The cation which is smaller in size
Will gain it faster.
gains faster. So I have my equation shall be H plus. It will gain one electron and it will form hydrogen, one hydrogen neutral atom. So this first change of the first change is basically what? From neutral, from positive to neutral.
Mm.
From positive to neutral. This is called as what? This is called as my primary. This is called as my primary change. Got the point?
Mm.
Got the point?
Yes.
And from H, so we're going to have two H plus, they will gain two electrons and they will form two H, and two H will thereby form H2, and this is going to be neutral. And again, this is going to be from atomic form to molecular form. This is called as my secondary change. Right? Raisa?
Yes, ma'am.
Any doubts?
No, ma'am.
Okay. So this is the primary chain and this is the secondary chain. Simple. All right.
Yes.
Okay. Now, understand. So this is the concept of cathode and anode. Okay. And
Mm.
what is happening at anode? So which cation remains in the beaker? Na plus remains in the beaker because
Mm.
more and more H plus, all the H plus will rush towards the cathode in the haste of gaining electrons. Okay. Then we have anode. Now, what do you mean by anode? What do you mean
Positive.
by anode? Anode is basically Na plus. Oh, sorry, OH negative. So we know that out of OH negative and Cl negative will go. So when we have Cl negative goes and becomes Cl neutral, and that one electron extra is lost to the rod. Or I would say it is lost to the anode rod. Am I right or not?
Yes.
So 2 Cl negative will form 2 Cl neutral plus 2 electrons. Am I right?
Yes.
What does that mean? So when we have 2 Cl negative, it gives me 2 Cl neutral. Yes or no? And then these 2 Cl neutral will convert into a molecule. I hope you understand this molecular formation.
Means electrons will be on that side. Left
Which
side.
side?
Left.
No. Cl negative is losing its extra electron. So as a product, what do I get? On the anode, I get a neutral chlorine and the electron in the rod.
Mm.
But initially what came? Initially came was Cl negative. So that Cl negative converted into what? Into the neutral atom and the electron.
Hmm.
Am I right or not? Got the point?
Yes.
So what exactly does that mean? Just tell me. So when we have the anode, okay, when we have the anode and when we have the cathode, what exactly do you think is going to happen? Tell me.
This electricity.
Got it? So this is the gas evolved at anode, and this is the gas evolved at cathode.
Hmm.
And what is left behind? OH negative and Na plus is left behind. So at the back, when the entire electrolysis gets over, NaOH is left behind in the beaker. And when NaOH is left behind in the beaker, what exactly does that mean? Tell me. It becomes extremely basic. So the question sometimes arises that what is going to be the pH that is going to be greater than 7 after the electrolysis is done? Are we understanding this part?
Yes.
Now, what questions are asked? So they'll give you this kind of question. So you have to predict the, this is called as preferential discharge. This is called as preferential discharge of ions. Okay. Preferential discharge of ions means that one of the ions will be discharged. Am I right or not?
Yes.
That one of the ions will be discharged out of the two, either the cation or the anion. Are we understanding?
Yes.
Any doubts in this?
Oh.
All right.
Hmm.
Okay. Now just see. Now just see. So sometimes we will have some questions. Okay. Now very important topic here that I'm going to tell you. So you will have two cations and two anions. Like for example, if I give you aqueous K2SO4, and if I want you to tell me the products of electrolysis of aqueous K2SO4 on platinum electrodes. On platinum electrodes. So platinum electrodes, they might say, or graphite electrodes, they might say. They might say anything. They can say platinum electrodes also, or they can say graphite electrodes also. You understand the point? So they can
Yes.
say platinum electrodes also, and they can also say graphite electrodes because both of them are passive electrodes.
Hmm.
So when both of them are passive electrodes, we are going to have the graphite electrodes and we are going to have the platinum electrodes. Got the point?
Yes, ma'am.
Right? How do we make it? Aqueous means it has water. So water will be H plus no H negative.
Hmm.
And K2SO4 here is going to be K plus and SO4 minus 2. K2SO4 here is going to be K plus and SO4 minus 2. Yes or no?
Yes.
So what is going to be the product here? Just tell me. What is going to be the product here? So I hope you're understanding. Got it?
Yes, ma'am.
Got it?
Hmm.
Now understand. So out of cations, you tell me which cation will be discharged, and out of anions, you tell me which anion will be discharged. So that means if you look at the cation series and if you look at the anion series,
H.
one of the one at the bottom shall be discharged preferentially. Okay.
Yeah.
So if you say like this series, so you have H here and K here.
Yeah.
Okay. And the series of anions is SO4 minus 2, the nitrate series,
H.
the fluoride, the hydroxide, then chloride, bromide, iodide. Am I right?
Yes.
So like that. So if you have sulfate, if you have nitrate, if you have fluoride, if you have hydroxide, if you have chloride, got the point?
Hmm.
What does that mean?
This H plus will be discharged
And
and
here SOH negative will be discharged. And whenever we see OH negative, we always send 4OH negative.
yeah.
Whenever we see Cl negative, Br negative, I negative, and F negative, we always see 2, 2, all of these because the fluorine exists in the form of fluoride.
Hmm.
All right. So now what are the products? You tell me. So we make a rough diagram. So we know that what is positive, what is negative. This is negative, this is positive. And out of H plus and K plus, H plus goes. And out of SO4 minus 2 and OH negative goes.
Yeah.
So what remains in the beaker? K2SO4. You understand?
Yeah.
Any doubts in this? So you understand that what is happening here, that at cathode, what we are going to write down. So at cathode, we are going to write down, at cathode, we are going to write down H plus. So when we send two H plus, so what exactly does it mean? When we have two H plus, they're going to gain two electrons and they're going to form 2H neutral. And the 2H neutral will form what? H2 gas.
Yeah.
Is that clear?
Yeah.
And at anode, what are we going to write down? OH negative is going to be sent. How many OH negative am I supposed to send at once? 4 OH negative. So it forms 4 OH neutral, am I right?
Mm.
And 4 OH neutral will give me what? OH, 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 OH. So it is going to give me 2 H2O. It is going to give me 2 H2O plus O2. All right.
Yes. Plus 4 electron.
Plus 4 electrons.
Yes, ma'am.
Correct.
Yes.
So now we have to make the electrons equal. So on the anode side, we have 4 electrons and here we have only 2 electrons. So if I make these electrons equal, only then my equations of cathode and anode are equal. Okay. So then what do? We have 2 electrons here. So we multiply the entire equation with 2. And then 4H we have. Got the point.
Yes.
Got the point.
Yes, ma'am.
So that is the idea we have. So we're going to have 4 cathode. We are going to have cathode. And we are also going to have anode. Understood the point or not? Just tell me.
Yes.
Easy?
Yeah.
How difficult is that? Simple. Okay.
Yes.
So now we see what exactly is going to happen. Just tell me. So we're going to have the anode and we're going to have the cathode. So that's the idea. Any doubts?
No, ma'am.
So that's what we have. So we're going to have 4 OH negative and 4 OH neutral plus 4 electrons like that. But if I have a product, now you tell me, what are the products of electrolysis of PB, PbF2? What are the products of electrolysis of aqueous PbF2 on platinum or graphite electrodes? One of the two will be given.
Hmm.
Tell me. Will you be able to do this? Just simply tell what will be discharged and what are the cations will be formed. Then I move on to the active electrodes.
Okay. So H plus name decrease. Okay, so H plus will be discharged.
Hmm.
OH again.
OH negative?
Yeah.
Okay. So you can write the equations now.
Mhm.
You can write the equations now. The equations of cathode and anode. So
Yeah.
at anode, what will you write? At anode, you are sure that we have two anions, OF negative and OH negative. We are sending OH negative. How many OH negative do you think we have to send?
4.
4. So this forms what? This forms 4 OH neutral plus 4 electrons. Am I right or not?
Yes, ma'am.
All right. Now just see. So we are going to have 4 OH neutral will give me what? 4 OH. And when this happens at cathode, what do you think is going to happen? At cathode, what do you think is going to happen? Just tell me. So we're going to have this anode And we're going to have this cathode. Cathode, we are going to have Pb getting deposited. Pb is plus 2. Because you look at this PbF2, that means this 2 comes at the valency of Pb. And it gains 2 electrons and it forms Pb solid. This was aqueous. Because aqueous would mean we have 2 cations and 2 anions. And then we look at the list. Any doubts in this process? Whole process. Got the point?
Mm.
Now, let's come to active electrodes. Now, how do active electrodes work? What are active electrodes? Active electrodes at cathode and anode are those which start reacting with the electrode, which start reacting with the electrolyte.
This we don't have to balance the equation.
You can do. I mean, that I'm expecting that at least you understood that.
Mm.
Right? Yeah.
Yeah.
So that means apart from graphite and platinum, all the electrodes, all the rods, and generally all active electrodes are generally metallic electrodes. Do you understand the point?
Yes.
All except platinum. You cannot you cannot include platinum as a part of the active electrodes. So except platinum, all of them are going to be metallic electrodes. Got the point?
Yes.
So when we're talking about the active electrode, what does that mean? Just tell me. Got it?
Yes.
So now you understand that when we have active electrodes which start reacting with the electrolyte are generally metallic electrodes, except the platinum electrodes. Got the point? Now, how do they work? Just understand. So let's say I have this beaker, and let's say I have these. Let's say I have these. Let's say copper rods. Okay. So let's say I have these copper rods, and copper rod, this is negative and this is positive. Both of them are copper rods. All right. They may or may not be same metals at the same time. You understand that? So I can have both copper rods. I can have one copper rod, one silver rod, and I can have one silver rod and one copper rod, whichever way you want to have. You got the point? So you understand what does that mean? So we are going to have copper rods. Got it? And here we have aqueous copper sulfate solution. All right. So battery exactly does the same thing. So battery exactly does the same thing. Got it?
Yeah.
So we are going to have Cu plus 2 and we are going to have SO4 minus 2. And aqueous ke liye we have H plus and OH negative. So basically we know this that out of copper and hydrogen, which is at the bottom, copper.
Yeah.
And out of SO4 and OH negative, which is going to deposit OH negative.
Mm.
Understood my point? Now, first we write down at cathode. It's very simple. The cation will go there because see, understand. You have to understand that who is losing electrons. So when I say the battery, this is going to be my anode and this is going to be my cathode. So when I say the battery acts like a pump and this battery basically transfers electrons from anode to cathode. The battery is transferring the electrons from the anode rod to the cathode rod. You understand the point?
Yes, ma'am.
So when the battery transfers electron from the anode rod to the cathode rod, what exactly does that mean? Just tell me. Just tell me. That we have Cu plus 2 and we have SO4 minus 2. So as usual, copper plus 2 will go there. And because these atoms in the copper rod will be of copper, I hope you're understanding. Because when I say the cathode is made up of copper, what does that mean?
It
What
was
does that mean?
forming solid copper.
Solid copper atoms. And the battery has tremendously filled it with lots and lots of electrons. So when copper from the solution, aqua solution comes here and it hits the rod, the copper plus 2 wants to become neutral. So it
Mm.
gains 2 electrons from the rod and it becomes copper solid. Are we understanding? It becomes copper solid. Are we understanding my point?
Yes, ma'am.
Okay. Now, when this happens, okay, when this happens, what does that mean? So, when you talk about anode, now understand the game changes at anode. Passive electrodes and active electrodes are exactly same till cathode. No issues. The cation goes to the rod, accepts two electrons, and becomes copper solid. Got the point?
Yes.
But when we reach anode, what do you think is going to happen? OH negative goes. Now, OH negative goes with the purpose of what? It goes there because it feels that, OH negative has lots and lots of electrons. So when you say we have OH negative, this negative will be lost. This negative electron will be lost to the rod. Because anions think what? That okay, now we have to go to anode and we'll have to give the electrons. That's what anions think. But anion this time he forgot one thing that no matter what, anion is basically made up of non-metals. Yes or no? O is a non-metal, O is a non-metal, H is a non-metal. So OH minus is basically a non-metallic anionic group. Is basically a non-metallic anionic group. Got the point?
Yes, ma'am.
So when it is a non-metallic anionic group, what does that mean? Got it? So
Mm.
now, and here we have copper atoms again in the rod. But you understand that when battery has pulled out electrons from these, what does that mean? So we're going to have copper plus 2.
Mm.
So this rod is filled with lots and lots of copper plus 2. So that means this rod is no longer neutral. It is no longer neutral. And when you say it is no longer neutral, that means it no longer carries. It is no longer neutral, and it carries copper plus 2 ions in it. Got the point or not?
Yes, ma'am.
Got it? So what does that mean? What does that mean? So you understand that when we have copper plus 2 and when we have OH negative, what does that mean? That clearly means that OH negative goes there, okay? And that OH negative wants to donate electrons, but at the same time, this OH negative forgets that now I am meeting up active metal. What do you mean by an active metal? What do you mean by an active metal? Which loses electrons. So now this metal has already lost its electrons. So you understand that rather than giving electrons, so if you have a competition between a metal, so you will say, ma'am, it's a less reactive metal, but I don't care. It's a metal. And metal's basic nature is to lose electrons.
Yeah.
So metal's basic nature is to lose electrons. And when we say that the metal's basic nature is to lose electrons, what does that mean? Just tell me. When I say the metal's basic nature is to lose electrons, what does that mean? Just tell me. That metal, if it loses electron, that clearly means what? Tell me.
That it will combine with the wedge. And the
Yeah,
will,
yeah. So copper, it will pull out the copper. So let's
yeah.
say if you have 100 copper plus 2 ions in the beaker, one copper goes here. You know, one copper goes here. You
Mm.
get the point?
Yes,
So if
ma'am.
you have 100 copper plus 2 ions here and one copper goes there, what does that mean? Tell me.
So the anode will decrease and the cathode will increase.
Yeah. So here it is going and depositing. So again it becomes 99. But OH negative goes to the anode and it pulls out one copper plus 2. Why? Because OH negative wanted to donate electron, but it forgot that in front of it, it is already a metallic reactive metal, which is donated electrons. And no matter how weak a metal is, but that metal will anyway lose electrons with regards to a non-metal. You know, when you compare a most reactive non-metal and when you compare a least reactive metal, then also the metal will have more tendency to lose electrons. So in that case, you understand that Cu plus 2 will definitely lose electrons. Am I right or not? And when that Cu plus 2 loses electron, what exactly does that mean? That Cu plus 2 is pulled out into the beaker. So basically 2 OH negative pulls out 1 copper plus 2 outside in the beaker, and again the count increases to 100. And again the count increases to 100. Am I right or not?
Yes.
Got the point?
Yes.
Any doubts in this?
No.
Got the point? So
Mm.
that is the idea. That is the idea. So when we have this particular beaker, you understand, when we have this particular beaker, what does that mean? So we are going to have this beaker, all right?
Yes.
Got it? And when we have this particular beaker, what exactly does that mean? That at anode, how I'm going to write down the equation? I'm going to say that OH negative will not lose electron this time. This time, this time the rod, the copper in the rod, the copper in the rod loses two electrons to the battery and becomes copper plus 2. That's the change that has happened here. So these two electrons, they go to the battery, they go to the battery. So I hope you're understanding that these two electrons here, they go to the battery and do what? These two electrons here go to the battery, okay,
Yeah.
and gets deposited here on anode. So the atom inside the rod becomes Cu plus 2. So the atom inside the rod becomes Cu plus 2. Am I understanding? Am I able
Mm.
to make you understand? Are we understanding this part?
Yes, ma'am. Mm.
So we're going to have Cu converting to Cu plus 2 electrons. Understood my point or not?
Yes.
Any doubts?
No, ma'am.
Got it? So that's the idea we have. So that's the idea we have. Any doubts on this?
No, ma'am.
Got it? So that's the only change we have. Okay. So let's suppose. So up till what time this concentration of this electrolysis will continue? Till the time we have so many copper ions that they can, they can compensate for the electrons, they can compensate for the ions which they go to the cathode side. You understand the point?
Yes, ma'am.
Any doubts on this?
Mm.
Got the point or no?
Yes.
Okay. Now let's suppose if we write down the silver electrodes, and I want you to write down the products of aqueous AgNO3. Predict the products of electrolysis. Predict the products of electrolysis of aqueous AgNO3. Predict the products of electrolysis of electrolysis. Now, there are two cases. You will understand. One with platinum electrodes and one with silver electrodes. So one with platinum electrodes and one with silver electrodes. All right.
Yes, ma'am.
So how do we go about it? Just tell me. So with platinum electrodes, how we have H plus and OH negative coming from water,
Yes.
and we have AgNO3. That means what? Ag plus and NO3 negative. Got the point? So when we have H plus and when we have OH negative, what does that mean? Right? Now
Yes.
understand. So we have platinum electrodes. So AH plus and Ag plus we have. So
Yes.
once we have H plus and once we have Ag plus, what does that mean? So
Ag will.
Ag plus will be deposited. So at cathode, what is going to be my equation? Ag plus. But you also decide at anode, OH negative will go. I hope you're understanding. According
Yes.
to the series of anions.
Mm.
So when we have this, according to the series of the anions, what do you think is going to happen? Just tell me. So at cathode, we are going to have Ag plus 1 and it is going to gain 1 electron and it is going to become neutral. Why? Because these are platinum electrodes. They do not react with anything. They do not lose their own electrons. So you understand what is happening. Because the platinum refuses to lose electrons. So in that case, OH negative from the anions has to come, give 1 electron to the rod, and then the rod will take this electron and give it back to the cathode. Because platinum atoms, they always remain neutral. They never lose their own electrons.
Mm.
So OH negative comes, it says that, okay, I have 1 extra electron, I'll give it to you. And then battery picks up that electron and gives it back to the cathode. So you understand that at cathode, when you're dealing with the cathode part, Ag plus 1 will do what? Ag plus 1 will thereby accept that 1 electron
Yes,
and
ma'am.
form Ag solid at cathode. And Ag from the beaker will go there. At anode, what is going to happen? At anode, what is going to happen? That OH negative comes and how many OH we are going to send? 4 OH negative. So we are going to get 4 OH neutral plus 4 electrons. Am I right or not?
Yes, ma'am.
4 OH neutral will form what, beta? 2H2O and O2.
Yeah.
Got the point?
Yes.
Got it?
Yes.
So this is what we have.
Mm.
Yes or no? So at cathode, Ag plus 1 goes and plus 1 electron and Ag solid comes. And again, we have to balance the electrons. So we multiply this equation with 4. So that's my equation at cathode and anode with platinum electrodes. But now, let's say we have silver electrodes. What does the change come? If we have silver electrodes, then what happens? Just see. If we have silver electrodes, how does the change come about? So we'll have the beaker. We'll have the silver rods this time. We have positive and we are also going to have negative. So what does that mean? So we are basically going to have this thing and we're going to have AgNO3 and we're going to have water. Am I right or not?
Yes, ma'am.
So when we have the silver electrodes and when we have Ag plus and NO3 negative and when we have H plus and OH negative. So H plus and Ag plus, which goes towards the cathode, Ag plus.
Mm.
Out of NO3 and OH negative goes, but this time we have silver rods, silver atoms. Silver atoms are not passive, they lose electrons. So now when OH negative comes, what does OH negative thinks? That okay, let me give my electron. But what does OH negative does not realize is that what is in front of me is definitely a less reactive metal, but that less reactive metal is not platinum. Platinum would definitely not lose electrons, but apart from that, no matter how less reactive a metal is, it will definitely lose electrons. Okay.
Yes.
So before OH negative donates its electrons, silver has already given its electrons to the rod.
Yes.
And then this Ag plus becomes what? So we are going to say what? We are going to say that Ag plus Ag from the rod was initially neutral. What happens at anode? Does anion loses electron?
No.
What happens at anode? So Ag from the rod will form Ag solid plus 1 electron. Am I right or not?
Mm.
Got the point?
Yes, ma'am.
So add anode is going to be Ag will be giving me what? Ag plus one electron. And at cathode, what happens? So why am I writing it like this? Because this is coming to the medium. Why? Because the moment it becomes Ag plus, OH negative pulls it out and forms Ag plus. Are we understanding this part?
Yes.
And at cathode, who is going again? At cathode, Ag goes. At anode, what goes? OH negative. So we are going to have 4 OH negative, and it gives me 4 OH neutral plus 4 electrons. And when it gives me 4 electrons, what does that mean? When it gives me 4 electrons, what does that mean? 4 electrons, so I'm going to again do it. So you understand that anode equation here and here. The anode changes, but you see the cathode. Sorry, at cathode.
Yeah.
This is at anode. And at anode, at cathode, what is going? Sorry. Ag plus goes. So if this is Ag plus from the solution, aqueous. It goes to the medium. Am I right or not?
Yes, ma'am.
Got the point.
Yes.
So where is the change actually coming? Is the cathode equation changes? You look at the cathode equation for the active and for the passive. So this is for the active electrode
Mm.
and this is for the passive electrode. Can I take a little longer class today?
Yes, ma'am.
15 minutes extra, right? So this is going to be at cathode, right? What does that mean? Just tell me. So at anode, the change basically comes out. At anode in the passive, which is platinum or graphite, it is the anion which holds the responsibility to donate electrons and complete the internal circuit. Whereas at cathode, you know, got the point or not?
Yes, ma'am. Yeah.
Got it?
Yes.
So that's the point. Now let's come to the point. Now we have a very different understanding. Okay. So what are we doing? Then let's assume we have this battery. This is the tank. This is the battery. If I look at the 3D view, you understand that, the electrodes are basically the 3D rods. Electrodes are basically 3D rods like that. Are
Yeah.
we understanding?
Yeah.
Something like that. So this is one rod and this is another rod. You see that? So this is one specific rod and this is another rod. And they're facing, and on these rods, basically what is happening? The metal is going to deposit. Yes or no?
Yes, ma'am.
Now, silver. Let's say silver goes and deposits. So why does silver deposits? We're going to have understanding that silver has one electron and it becomes Ag solid. So when silver goes and it deposits on this rod, you understand. Let's say we continue this electrolysis for very long. Let's say we continue this electrolysis. Let's say for 1 hour or 10 hours. So you understand that silver will be continuously depositing itself. And when silver will be continuously depositing itself, it is exactly going to happen what? When silver will be continuously depositing itself, what exactly do you think is going to happen? So silver basically deposits on the top.
Yeah.
So when silver deposits itself on the top, what does that mean? Tell me. So silver will make a layer on this. And once the silver will make a layer on this, what do you think is going to happen? Just tell me. That silver will start making a layer and it will start depositing. So a small silver layer will be depositing on itself. You understand? So this much thick silver will deposit. Do you understand?
Yeah.
So this thick silver will deposit. Are we understanding my point?
Yeah.
What does that mean?
Form of coating.
Tell me. So when this thick silver deposits, what does that mean? This is there. So the question says that if we carry out the electrolysis for let's say 10 hours, so where do you think that the silver will be depositing? What will be the thickness of this silver layer? You have to calculate this thickness. So you understand that let's say this is, if you look at this now, so if you think that this is the face of silver, or if you think that this is the rod, this is the face of the rod, and on this face silver is depositing. So do you realize that a very thin, this green thickness is actually silver?
Hmm.
So do you think that there's a very thin layer which can be in microcentimeters or very small layer? So do you think that this is actually a very thin rectangle or cuboid which is being formed over this? And the electrode definitely is at the back.
Hmm.
The electrode is definitely at the back, but the face which is actually available for silver for depositing, on that phase, a very thin layer of silver gets deposited. Are you understanding my point? Because no matter what, some silver might go here, some silver might go here, and eventually this entire phase gets completely covered with silver. So there is a very thin thickness, but that thin thickness is definitely there. Are we understanding the point?
Yes.
This thin thickness is definitely there. Got the point?
Yes.
So let's what do we assume? Let's assume that thickness to be. Let's assume that thickness to be T. Okay. Now tell me, if this is the length of the this and this is the breadth, or this is the length and this is the breadth, let's say. So length into breadth, this is going to be the area of the plate.
Yes.
This is going to be the area of the plate. So that is going to be L into B. And what is the volume of this so thin volume of the silver chloride? Or I would say, what is the volume of this metal chloride? Why am I saying metal chloride? Because that metal is getting deposited on the rod. So what is the volume of the silver cuboid? That is going to be length into breadth into height. So can I say this thickness? This is basically the height, H. Yes
Yeah.
or no?
Yeah.
Understood. So when I say the volume of the silver metal, it is going to be L into B into T. What is L? L into B is area of the electrode. So this is going to be what? This is going to be the area of the electrode.
Yes.
This is going to be the area of the electrode. Yes or no?
Yes.
So can I say the volume is going to be area of the electrode into T? T here is what? Thickness. Okay. So let me call that thickness is capital T because small t we are representing with time. Now understand. If I say the density of silver or metal is rho. So can I say mass of silver upon volume of silver is going to be density of silver? I hope you're understanding.
Yes.
So what is the volume of silver which is getting deposited? This is the volume of silver. So can I say mass of silver upon volume of silver is length into breadth. Length into breadth is of the area of the base of the electrode.
Hmm.
Why am I saying area of the base of the electrode? Because that's where the silver is going and depositing. Mass of the silver into thickness is density of silver. So what will be the mass of silver? That is going to be this rho AT. Because L into B, I'm calling it as Area of the base. Am I right?
Yes.
Got it? So this is exactly going to be the mass of the silver. And then what do we say? And have we learned the method that Z I into T, current into time? This is also the mass of this metal deposited.
Yeah.
So can I say that ZIT is going to be rho AT? How do I remember it? I call density as D. So I remember it as Z equals to that. I remember it like that. But I hope you're understanding that capital T here is the thickness of the metal.
Yes.
So they will give you the plate area, they will give you the electrode area. A is the area of the
Electron.
A is the area of the electrode plate on which the metal is trying to deposit.
Yes.
And D is the density of the metal on which the metal is trying to deposit. And D is what? D is going to be the density of the metal plate. Z is what? If you understand, Z we learnt as what? The mass, the molar mass
Yes.
of the metal upon N into F. N is the valency of the metal. IT. Where I is what? The current. The current has to be in amperes. And T here is going to be what? T here is going to be time. And T here is going to be time. Am I right or not?
Yes.
Got the point or not?
Yeah.
So that is the idea we have. That is the idea we have. This is going to be the idea. So we're going to have the thickness of the metal. That is the area of the electrode plate on which the metal is trying to deposit, density of metal. And using this formula, we are going to solve all the numericals. I hope you're understanding.
Yes, ma'am.
Okay. And one more theory class. We're done with this chapter. Okay. And one class on numerical. We are good to go. All
Okay.
right.